Hi guys, and welcome to this, my video on the 2021 Further Maths Exam 1 for the Northern Hemisphere timetable. Further Maths exams. Now, no safety net with this one. No VCAR exams to make sure I haven't made any silly mistakes. So if there are any errata with this, please put them in the comments below and I'll add them to the video. Over on mathsguru.com, I will have the opportunity to individually re-record particular questions. If you want the definitive, head over to mathsguru.com, sign up absolutely free, go to the exam section, you can look for individual questions, fire up the 2021 NHT exam paper 1, and then you'll be able to see if I've re-recorded a solution for any errata. So I'm going to do my level best. But it does actually make me wonder. I did some of the questions last night and I was like, that's a little bit tricky. So yes, here we go. Data analysis. So these are probably going to be the solutions just for the core module, and then I'll do the core stuff, then the modules, and then I'll do paper 2. So data analysis. The histogram below shows the distribution of the mean number of years of schooling of women aged 65 years and older in 187 countries. Okay, important information there, 187 countries. All right, the percentage of these 187 countries, they've given it to me again, where the mean number of years of schooling of women aged 65 years or older is less than 1 year is closest to. So less than 1 year is going to be the numbers less than here. Okay, so what I'm going to do is zoom in to make sure I get this right. Each of those little ticks stands for 1. So there are 43 women who are, less than 1 year. Okay, so 43 out of 187, so we do 43, he says, typing into the wrong screen already, 43 divided by 187 gives me, times that by 100, put to a percent, is 23%. So as far as I'm concerned, B would be the correct answer. The median of the mean number of years of schooling women and older in these ages is closest to, right, median. So the median. I know that to find the middle number, we want to take the number of data items, add 1, and divide by 2. So 188 plus 1, you're going to turn around and say, why on earth are you doing this on your calculator? I am tired of making mistakes, all right? So again, I don't know why I just did 188. So 188 divided by 2, let's try that one again, 94. So I want the 94th data item. That will be my median. So let's go back. Well, we already know that there's 43 there. There's 24 there. There are 10, 11, 12 there. So if I do a running tally, 43, 67, 43, 53, 63, 67, 77, 79. So up until and including this there are 79. How many did I need the 94th? All right, so there's 10 here. So we've got another 10 here. So that will give me 89. And we wanted the 94th data item. So because there are, how many in there? 4, 5, 6, 7. 89 plus 7, 89 plus 7 gives me 96. So up to and including this bar here, there are 96. We want the 94th, so in which case our median must fall somewhere between the 4th and the 5th, 4 and 5, he says. And so the one that falls somewhere between 4 and 5 would be C, 4.4. Question number 3, the variable is number of family members. Now, whenever I see these type of questions, I always put things like, so this is most definitely numerical, and it's going to be discrete because you can't have a decimal number of people, and age group, that is actually going to be categorical because we've got them in categories, and there is ordinal because there is a sense of order. We know that those numbers have an order, and so let me see, they are numerical and ordinal variable respectively. So a numerical and an ordinal, a numerical variable and a nominal variable and a continuous variable. Now, question 3 is C. A class of 25 children in year 5, 15 girls and 10 boys sat for a maths test. The mean score for the 15 girls in the class is 28.5. The mean for the 10 boys was 25.5. The mean test score for the whole class is, this is a bit of a trick. And again, what you need to do, remember, to find the mean, and let's call it X bar, or you can call it mean, or whatever you want to do, is we need the total scores of all the kids divided by however many kids there are. You can't just add those two numbers together and then divide it by 2. So if each student in the room on average got 28.5 for the girls, then we can work out their total score is 15 times 28.5. I'm going to add on the total score of the boys, which was 10 times 25.5, because each of those boys on average got 25.5. And then I would divide that by the total number of people in the room, which is 25. Okay, so firing up my CAS. Let's do some brackets so that it all looks right. 15 times 28.5, close the brackets, add, open a set of brackets, 10 times 25.5, and we're going to divide that by 25, gives me 27.3. And the good news is that's one of my answers, so D is the correct answer. The amount of salt in a salt container in grams is approximately normally distributed. Right, so as soon as I see that, I draw myself a normal distribution, and then I put my mean of 756, and then I split that into 3 sections. I tend to make them fairly wide simply because my handwriting is pretty big, and a standard deviation of 2 grams. All right, so 756, 758, 760, and 762. So 56, 58, 60, 62, and then 754, 752, and 750. All right, I just do that as a matter of course, because we know that the mean is that middle number here, and the standard deviation just means that each of those standard deviations go up by 2. In a random sample of 1,000 of these salt containers, the number of containers expected to contain less than 750 grams. Whew. So less than 750 grams. Now, if you've got that diagram, you'll know that that is equal to 0.15% of my whole data. All right, so I now need to find 0.15% of 1,000. So 0.15 divided by 100 to turn it into a decimal, times it by 123, gives me 1.5. All right, so in a random sample, the number of containers expected to contain is closest to, in that situation, 2 would be the answer that I would suggest was correct. Ruth sells eggs. From past experience, Ruth knows that the mean weight of the eggs she sells is 56 grams. All right, again, this is another normally distributed question. So there's my normal curve. What have I got here? Mean weight is 56. 2.5% of the eggs that she sells have a weight that is greater than 65. Now, if you again remember, the 2.5% is actually this bit here. So that's them telling you that there is 65 on my second standard deviation. It's a bit of a trick. Assume that the weight of the eggs, Ruth, are approximately normally distributed. The standard deviation of the weight of the eggs is, well, what we now know is that that distance there is 2 standard deviations. So if I do 65 minus 56 gives me 9. So divide that by 2, because there's 2 standard deviations, give me 4.5. So E, as far as I'm concerned, is my correct answer. Question number 7, a college awards a certificate of high achievement to a student. The student's scores for subject blah, 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 10, in the top 10%. Now, I'm going to be honest with you guys, this question's thrown me a little bit. I'm going to give my answer. Hopefully it's going to be the right one. All right, but I'll explain why it's thrown me a bit. So SASSI basically studies these 4 subjects. It gives you the mean and the standard deviation for each subject and what SASSI got. Now, the minute I saw that, I'm like, oh yay, Z scores. Brilliant. It then goes to say, assuming the student scores for each of these 4 subjects are normally distributed, even more like Z scores, the number of certificates of high achievement the SASSI received was. So she's got to be in the top 10%. Now, I don't know about you, but when I was thinking about this question, I was like, well, the top 10%. There's nothing that we do that gives us the top 10%. If you remember, the closest I can get is the top 2.5% of the data, yeah? Because otherwise, this one here is something like 18.5%. So, if she's going to get a Z score, she needs to be up here somewhere, all right? In that top 2.5%. If she's in there, she's going to get a certificate, right? So, what I then went on to do was find the Z scores for all of these. So, if we do Maths A, the Z score is equal to, remember Z is equal to X minus mu on sigma, where X is the data item. So in that situation for Maths A, we had X was 80 minus 69 divided by the standard deviation of 12. So 80 minus 69, again, I know this is random, I'm doing it on a calculator, but I don't want to get these wrong. 11/12. All right, so that there is less than 1. So as far as I'm concerned, because she's got a z-score there of less than 1, there's no way she's in the top 10%. So I'm going to say no to Maths A. If we now look at Maths B, doing exactly the same thing, remember we've got a new score now of 85 minus a new mean of 68 divided by a new standard deviation of 8. So 85 minus 68 gives me 17. So that's going to give me 17 on 8. So 8/16, so that's going to give me a standard deviation of 2.1, sorry, z-score of 2.1. That well and truly puts her in the top 2%. So I'm going to say yes, she's going to get one for Maths B. For physics, z-score is going to be equal to 81 minus 69 divided by 13, he says. Minus 69 gives me 12 on 13. Again, that is going to be less than 1. So no, that's not going to put her at the high end at all. And so then we've got chemistry. So the z-score is going to be 81 minus 62 on 9. So 81 minus 62 gives me 19 on 9. And again, that's about it's going to be 2 point something. So again, that's going to put me in the high end. So as far as I'm concerned, for chemistry, she's also going to get that because she's way, way, way in the top 10% of the students. So in that situation, I'm going to say C. She's going to end up with 2 certificates of high achievement. Again, if you disagree with that, please, please, please let me know. If there's another way, because I've sat and racked my brain for that question for quite some time, and I was like, we'll just go with it. The blood pressure, normal, high, and age group of a group of people recorded. The results are shown in the two-way frequency table below. Awesome, let's scroll up a little bit. In this group of people, the percentage, very important to know percentage, of people who have high blood pressure, so there is my high blood pressure, and are in the 70 to 79 age bracket. Right, so we now know as a percentage we need the number of people we're looking at, which is 37, divided by the total number of people. So we're going to do 38 plus 37 plus 29 gives me 104. We want that as a percentage. So 37 divided by 104 times that by 100 gives me 35.5 blah, 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 blah. And so when it says it's closest to, we're going to say 35. Yep, because if I round that up, it's going to be, well, in fact, it's nowhere near closer to 37 than it is 35. So I'm going to go C again as my correct answer. Okay, question 9 goes on to say, in this group of people, the percentage of people in the 60 to 69 years age group, so I'm going to rub this out now because we're dealing with 60 to 69 years age group, who have normal blood pressure is equal to, so now we've got normal blood pressure. So there is 42 out of, so 42 divided by, let's add those two together first, 42 plus 38 gives me 80, 42 divided by 80 times it by 100, all right? So 42 divided by 80 times by 100 is my working out 52.5, which gives me E as my correct answer again, because it's nearest to. All right, use the following information to answer questions 10 and 11. Awesome. Bone length in millimeters is one of the metacarpal bones, and height in centimeters recorded for a sample of 9 people. Awesome. The results are shown. The mean and standard deviation of bone length for this sample of 9 people in millimeters is closest to. So we want the bone length and we want the mean and standard deviation. So I'm going to do that on my CAS calculator. I'm going to put the data in and then come back. Okay, so there's my data in now, and I've got 9 data items. Again, I always scan up just to make sure that I've not put anything stupid in there, that I've not made 3 digits or whatever else. I'm fairly sure those are my numbers: 39, 41, 48, 49, 46, 43, 47. Okay, what do we do now? Well, we go menu, statistics, stat calculations. My calculator for some reason is, or my computer is randomly doing something. One statistic, again, number of lists, still 1. My X list is not bone, I mistyped, bone, and we'll just accept the rest of the information. Scroll up to the top so we know what we're doing. And what does it want? It wants my mean is 45.4, so my mean is 45.44, so that's those out of the window. Whoops, the daisy. That's no, no, and no. All right, 45.4. And then my standard deviation, well, we want this SX one, which is 3.88. So B there would be my correct answer. Again, bang that in the calculator, off you go. Same information, the equation of the least squares line, I'm going to scroll up for a moment because probably my fat head's in the way. The equation of the least squares line that enables bone length to be predicted from height. Now, bone length from height. Be very careful there because that's actually telling us our X value and our Y value. Because we want bone length to be predicted, that's going to be on my response variable, and height is going to be my explanatory variable. All right, so that's useful to know. What do I need to do? I need to put that information back in my calculator and then get it to do a regression analysis. Okay, so once again, there's my data in 173, 175, 177, 183, 172, 163, 157, 178, and 171. And again, I check these at a matter of course. There is nothing worse than losing a mark because I've just typed something in wrong. So again, what are we going to do? Menu, statistics, stat calculations. Let's do linear regression A plus BX. My X list, now remember, we've said the X list is my height because I'm going to have bone length predicted from height. Yeah, there we go. So all the rest of that is fine. And we've got this information here. So if we remember, our bone length is going to be equal to, so we're looking for the A value is minus 28.56 or 6. So minus 28.6. I'm just going to write this here. So minus 28.6. Again, A and B are the only values that can be correct for me. And my B value, A plus BX, is 0.431. Okay, so plus 0.431. Now you're going to turn around and say, well, hold on a moment, both A and B are in fact the same, but they're not, because again, because I've done my graph here of bone length, then I know that that's my Y value. So my equation has to start bone length equals, that can't be right, A is my correct answer. Question 12, a least squares line is used to model the association between arm span in centimeters and height. So you've got arm span and height in centimeters. With the variables of the y-intercept and slope left unrounded, so this is testing your rounding, the equation of the least squares line was found to be this. Okie dokie, so we've got that massive thing there, with the numerical values rounded to 5 significant figures. 5 significant figures has to have 5 figures in it, all right, 5 digits. The equation of this least squares line is, so to 5 significant figures, if I have minus 67.680400231, I start counting at my first digit that's not a 0. So we start counting there, and I want 5 of them. 1, 2, 3, 4, and 5. Does the 4 change the 0? No, it doesn't. And so as far as I'm concerned, we would have minus 67.680. The next one, 1.355759005, same thing. Start counting at the first non-zero digit. 1, 2, 3, 4, 5 will be 1.3557, but we have to take account of this 5 here, which is going to change that 7 into an 8. Okie dokie. So getting rid of all that then, and then getting rid of that rubbish there. As far as I'm concerned, 1.3558 times height. Well, we can't have that, that, or that, so it's got to be A or B again. And again, I'm going to go with B as the correct answer, but I've got a sneaking suspicion that the 0 doesn't get counted, but I'm going to leave it. B, I'm going to go with that one there. Again, if you think I'm incorrect, let me know. The table below shows the mean life expectancy in years and per capita income in dollars for 13 countries. A scatter plot displaying the data is also shown. Awesome. There we go. Lovely, lovely, lovely. A log 10 transformation applied to the variable income can be used to linearize the scatter plot with log 10 income as the explanatory variable. Oh, I've done it again. The amount, if I got paid for every single time. So log 10 income. And what was the other one? Log 10 income, because we're dealing with this question, life expectancy. So we've got life expectancy there. All right, here we go. So with log 10 income as the explanatory variable, the equation of the least squares line fitted to the linearized data is closest to. All right, so I'm going to put the data into my calculator and then I'll come back. Okay, here we go then. So 69, 44.12, or so 4412, 39060, 1040, 4261, 173, yep. 26930, 22330, 12610, 8282, 5721, 4717, and 2581. Okay, there we go. So there's my information. It's in. Hopefully it's correct. So let's do menu. Actually, let's not do that. I could do this, but let's try something different. He says, hitting the wrong key altogether. So I'm going to do control and insert and data and statistics. Click to add a variable there. So what did we know was my, so income? No. Actually, let's do that one again. There's my income. I got to do log income. Oops, log income, forgot that. So what I want to do is I want to do equals log. Actually, let's bring up our, where's my log? It's there, control, log 10 of income. Hopefully it will accept that. There we go. So there's my log. Almost made a mistake. Oh, stupid. All right, now I'm going to go back to here. And what I've got along the bottom, I've got my log 10 income. He says, let's go back up. Log income. And my variable there was going to be life expectancy. So there's life. And okay, interesting. So what do I want to do now? I want to do menu, analyze, regression, and show linear AX plus B. And there we go. Now obviously it does the Y and the X for me simply because it doesn't know the log whatever. But again, there I would have my life expectancy would be equal to 32.3539 plus 10.3181 times the log 10 of income. That's what my calculator reckons. Now fingers crossed that's going to be an answer there. 32 point. Now obviously it's done it to two decimal places. So 32.35 plus 10.32 is my correct answer. All right, so the scatter plot on page 9, which is the page before, can also be linearized using a square transformation applied to the variable life expectancy. The equation of the least squared line for this linearized data is given as such. Awesome! When this equation is used to predict life expectancy, so when it's used to predict life expectancy in years for a country with a per capita income of $20,000, life expectancy is closest to. All right, so basically they're just trying to turn around and say, well, we know now that life expectancy is equal to 4801.6 plus 0.4715 times the income, which is $20,000. So again, what I'm going to do is put into my calculator that value. So let's flick back to our calculator screen. 4801.6 plus 0.04715 times 20, 1, 2, 3. There we go. That's going to give me that value there. So that is my life expectancy squared. Sorry. So my life expectancy squared is equal to 5744.6. So what I'm now going to do is to get rid of that squared, I'm going to square root my answer. So my life expectancy is the square root of 5744.6, which gives me, he says, control that of my answer, not quanta, of my answer, gives me 75 points. So once it closest to 76 years. As far as I'm concerned then, D would be my correct answer. The seasonal index for the number of cars sold at a car dealership is equal to 0.8. To correct for the June car sales for seasonality, the actual number of cars sold should be. All right, I teach this stuff all the time, and it's very, if you've got the Cambridge textbook, it's right there at the very, very end. Okay, to work out whether we need to increase or to do it, we actually do 1 over the seasonal index, which is 1 over 0.8. So if I look at my calculator, 1 over 0.8 gives me 1.25. Now that's a decimal representation, which basically means it's 125% of my seasonal, of my actual value. So what that tells me I need to do to correct for the June car sales for seasonality, I need to increase by 25%. The table below shows the monthly rainfall in millimetres recorded at a weather station over a 1-year period. I know where this one's going. The 6 mean smooth monthly rainfall centering on May. Now, because it's 6, we've basically got to choose 6 values to the left of May, 6 values to the right, and then average them. All right, so what I'm going to do is my 6 values here, so 1, 2, 3, or 1, 2, 3. I'm going to choose those values there, and I'm going to take an average. So what am I going to do? Let's do this way, because I normally retype all the values in, but let's be cleverer. So 80.6, 56.4, 59.3, 93.5, 186.4, and 83.2, and I'm going to divide that by 6. Here's my answer. So we know on the left hand side that's going to be 93. Oh, I've done it again. 93.2333. I'm not going to round any of these values until the very, very end. Now what I'm going to do is I'm going to basically repeat the process, but on this side, using 6 values centered around that side. Okay, hopefully this all makes sense. So I'm going to go from 56 all the way up to 126.4. So now I'm going to copy that down. I'm going to edit it. I'm going to get rid of the 80.6 because that's no longer there, but I'm going to put in 126.4. Hit enter. Now that gives me and again 100.867. How am I now going to do this? I add those two values together and divide by 2. I take the average of those. So I'm going to do that. I'm going to add it to that, and obviously notice my calculator has got so many more numbers. I'm going to divide that by 2, gives me a 97.05, and because it's looking for closest to, that would be 97.1b would be my correct answer. Right, financial maths, here we go. The graph above could represent the value of the balance of a savings account earning simple interest. So simple interest, they get a fixed amount of interest every single year, all right? A balance, if it's interest, it's going to go up. So it could be the asset, let's move that up again. An asset as it depreciates using a flat. Well, depreciation of an asset means the graph would actually go down. It can't be B. A perpetuity earning compound interest. Well, a perpetuity basically has a flat line because the amount in the account stays the same. The whole point of a perpetuity is you effectively live off the interest. No. An annuity from which regular payments are withdrawn. Well, an annuity, again, would go down because it's like a savings account. All right? So I'm going to say no. A reducing balance loan with interest-only repayments. A reducing balance loan. Now again, if it's reducing balance, it'd be going down. I'm just going to think about D again. An annuity from which equal regular payments are withdrawn. No, it can't be. An annuity from when money's it's going down. That's the whole point of annuity. So as far as I'm concerned, A is the correct answer. And because it's the first question, it's supposed to be relatively simple, all right? Let's make that bigger. So the value of an investment in dollars after n years could be modeled by the recurrent relationship shown below. Okay, this investment earns compound interest rate at 5% per annum. Okay, but it's compounded quarterly. What is the value of R? Well, if you remember, it's R is equal to 1 plus R over 100, where this rate here is my interest rate. Well, in this situation, it's R divided by the number of compounds, all right? So R divided by N. So for me to be able to work this out, I'm going to do 5% per annum. I'm going to divide it by 4 because that's going to give me my quarterly because that's what it wants. Yep, that's what it wants. And then I'm going to divide that by 100 and then add 1 to it. The reason I'm dividing by 100 because it was a percentage. So 5 divided by 4, divide that by 100, and we're going to add 1 on. It gives me 1.0125. C is the correct answer. The value of a computer purchased for $5,000 is depreciated by 10% per annum using the reducing balance method. Okay. Recursive calculations can determine the value of the computer after n years. Which of the following recursive calculations is not correct? All right, so we would know there that we'd have V0 was equal to 5,000, and to get to V of n plus 1 would equal to V of n times, well, 10% reduction would be 0.9. So what I'm going to do is I'm going to put 5,000 into my calculator, and then I'm going to do answer times 0.9. Hit the first one. So in which case V1 would be 5,000 times 0.1. So V0 is definitely 5,000, that's right. So again, they're looking for one which isn't correct. V1 is 0.9 times 5,000. Yep, because that's what that's on there. V2 would be 4,500 times 0.9 because that's my answer there. Remember, recursively, I take the previous value and multiply it. So 0.9 times 4,500 is correct. Hit enter. 4050. Aha. So V2 was 4050. So V3 should actually be 0.9 times 4050. So D isn't correct, and if I hit that, then actually E is correct. So D would be my incorrect answer. Leonard has invested an amount of money in a perpetuity. Remember, perpetuity, right? The amount stays the same. You live off the interest. The perpetuity earns interest rate at a 4.8% per annum. Interest is calculated and paid monthly. That's important as well. 4.8 per annum. Interest is calculated and paid monthly. If Leonard receives $1,600 per month from the perpetuity, then the amount he has invested is. So first thing I'm going to do is work out my monthly interest rate. So it's 4.8 divided by 12. So it's 4.8 divided by 12, which gives me 0.4%. So 0.4% of my investment, let's call it P, my principal, is the interest. That's equal to 1,600. So I know that 0.4 divided by 100 gives me 0.004 times P is 1,600. So I'm now going to divide 1,600 divided by my previous answer is going to be 4 and 1, 2, 3, 4, 5 zeros. Well, in fact, it's the only one there. So it's the only one that actually is there. So D would be my correct answer. Derja invests $250,000 in an account that pays interest at a rate of 3%. So here's my principal, rate of 3% per annum, compounding monthly. He makes additional payments of $250 each month into his account. The value of Derja's account in dollars after n months can be modeled by the recurrence relationship shown below. The balance of Derja's account first exceeds $500,000 at the end of year. With this particular question here, this would be nuts to try and do this because basically this is each month. All right, so what you'll see here is I started doing this using the recurrence relationship on the TI Inspire. That was nuts. I was like, I'd already done it for like 20 times. I was like, I'm never ever going to get to my answer. I'll be sitting there forever. So I think in this situation here, although they've given me a recurrence relationship, I'm going to fire up my financial solver. So here's my financial solver. N is what I'm trying to find. Okay, so have they given me an interest rate? They have. It's 3% per annum. My principal value, all right, invest. So I'm giving money, I'm unhappy. So that's minus 250,000, and he's making payments of 250. So again, that's minus 250. He says, putting a negative sign in there. Future value, we're basically looking for when it's 500,000. So 500,000, and the payments per year are 12, and compound periods are 12 as well. So now if I hit enter there, I basically get that it'll reach 500,000 in 215 months, 215.8 months. Let's say 216 months. Now, how does that help me? Well, if I now go 216 divided by 12, that's going to give me 18 years. So what we now know is that after 18 years, it will first exceed 500,000. I have no idea how I would do that other than using a financial solver, and I think that there was a bit of a curveball. So let's just check there. Let's just put this here as 216, and we'll now work out my future value. There we go. So after 216 months, which is 18 years, I would have had just over $500,000. All right, Cherie has purchased a boat for $90,000. All right, it depreciates using the reducing balance method for the first 2 years. The annual depreciation rate was 15%. Okay, Cherie then changed the annual depreciation rate to D%. After 3 more years of reducing balance, it got to there. All right, so the changed rate D is. There are lots of ways of doing this. But what I now know is that if I want to find out the value after the 2 years, I can take 90,000. I can times that by 1 minus my value of my depreciation, or in this situation, 1 minus 0.15. and I would raise that to the power of 2. Why? Because it's 2 periods. So again, on my calculator, 90, 1, 2, 3, I'd multiply that by 0.85 to the power of 2. 0.85 because that's what I'm going to end up, that 1 minus 0.15. Yeah, that's my reducing balance. So when I hit enter there, that's going to give me $65,025. All right, so that's how much my boat's worth at the end of the 2 years. She's now changing the value for 3 years. So I now know that at the end of that, she's going to be $43,561.67. That's going to be equal to, now in this situation, 1 minus D, right, squared, no, in this situation, cubed, because it's for 3 years, times the original amount of 65025. How do we do this? I can basically just put it in my CAS calculator. I'm going to do solve. I'm not going to use the value of D. I'm going to do 43561.67 is equal to, in brackets, 1 minus, I'm going to use D actually, power of 3. And I'm going to times that by 65025, comma, D, hit enter, and out comes D of 0.125. Now what on earth does that mean? Now that value of D there is 0.125 as a decimal. When I times that by 100, I'm going to multiply that by 100. That will give my percentage of 12.5%. C is 12.5%. There may be other ways of doing this question. That was the one that came to me. But let me know below or wherever if you can find another way of doing it. Anne has taken out a personal loan of $5,000. The interest for this loan compounds quarterly and makes no repayments, and after 1 year she receives that. The effective annual rate of interest for the first year of Anne's loan is closest to. I'm going to fire up the financial solver again. Okay, Anne has taken out a personal loan for, let's just delete all of this for the moment and let's go back up. Interest is... Anne has taken out a personal loan of $5,000. So personal loan, she's given money is that. She's making no payments. The future value is she owes, so that's money she's got to give back, 5325.14. Payments per year, the annual effective interest rate is 4, doesn't really matter. Compounds per year is 4. Number of periods, we'll say, is 4. And so my interest rate will be 6.35%. So 6.35%. And again, let's rub that out. I'm going to ban the use of highlighters. 6.35 would give me B as my answer. Final question in this section. Vittorio has borrowed $40,000 to go on a holiday. Brilliant. Interest on this loan is charged at a rate of 8.3% per annum, compounding monthly. Vittorio intends to repay the loan over 4 years with 48 monthly repayments. After 47 equal repayments of that, he finds that a small adjustment to the final repayment is required to fully repay the loan to the nearest cent. Compared to the 47 earlier payments, the final repayment will be... Hey, okay, so he's making 48 monthly installments, 12 yeps. Okay, so his interest rate was 8.3%. His principal, he borrowed 40,000. His payments were after, so minus 982.16. Future value, I don't know, because we're going to work it out. Payments per year is going to be, so actually I'm going to change that to 47. And I'll explain why in a moment. Future value, we're going to try and work out. Payments per year, it's compounding monthly. So it's 12, 12, there we go. So if I look at my future value, after 47 payments, he would still owe, $975.39. Now the trick to the question here, I think, is that actually his final payment is going to attract interest as well. All right, so we've got to be careful there. So I'm actually going to work out 48 payments to work out his final value is actually going to be he's going to overpay by 0.02757. So he's going to overpay by 3 cents. Right? So in fact, once he makes that final payment, that 48th payment, he should realistically pay 3 cents lower. So I'm going to go B is my correct answer. All right, so the final repayment will be 3 cents lower. A lot of people get tricked with this question because they go, oh, 47 payments. But what you got to realize is that the money he still owes, that $975, he's still going to be charged interest on for that last month. And a lot of people get tricked on that. Okay, so understanding the number of months and payments higher or lower is going to be really, really important. And that, ladies and gentlemen, is the end of section